Alright guys, welcome back. So the next topic that we're going to talk about is the line of best fit. This gives us a visual representation of how do our scatter plots relate to each other. So let's jump into an example here. We're going to talk about a collection of data between how long a student studies versus how their test scores related to it. So whether a student studied for 1 hour, 2 hours, 3 hours, 4 hours, or 5 hours. Because this is the independent variable, this is going to be our x coordinates. Alright, then the test scores, which are dependent on the time studied, they're going to be our y coordinates. So we have a varying amount of test scores in this data. So the table shows the relationship between the time a student spends studying and each week of their test scores. So let's plot the points. Alright, so we've got our first point, 150. So I'm going to go 1 on the x-axis, 50 on the y-axis. Our second point is at 260, so 2 on the x-axis, 60 on the y-axis. Our next data point is at 365, so I'm going to go 3 on the x, 65 on the y-axis. Next point is also at 3 hours, but now 74 for the test score. So I'm going to put that right between 70 and 80. Our next student studied for 4 hours, and they received a 78 on the test. Let's put that right about there. The next student studied for 4 hours as well, but they received an 89 on the test. It's going to be right in between 80 and 90 in the graph, closer to 90 though. Then, one of our last students, he studied for 5 hours, and he received a 91 on his test. So right there above a 90. And then our last student, he also studied for 5 hours, but he got an 85 on the test. Alright, so now that we've plotted the points, let's look at two specific points. Let's look at the point at 150 and the point at 591. Why do you think I would want to choose those points? Well, the simple answer to that is because if I draw a line between those 2 points, it pretty much describes the relationship between all the points on that data set. So that's going to be our line of best fit. Alright guys, think back to semester 1 when you guys learn about linear equations. We're now going to have to solve for our slope and find our y-intercept to create our linear equation here. So, first thing we got to do is find the slope. Remember, that's your change in y over your change in x. So y2 minus y1 over x2 minus x1. And if I'm labeling points here, our x1 is 1, our x2 is 5, our y1 is 50, and our y2 is 91. So let's calculate the slope. I'm going to have I'm going to start with my y2, so I'm going to have 91 minus 50 divided by my x2, which is 5, minus my x1, which is 1. 91 minus 50 is 41, and 5 minus 1 is 4, so 41 divided by 4 is going to give us a slope at approximately 10.25. Alright, so from our slope, let's find our y-intercept. Remember, the equation can be written as y equals mx plus b, where m is your slope, and you can use any of your points on this scatter plot now. Well, let's use the points either 150 or 591 to find our y-intercept. So let's take the point 150. I'm going to use the y from that point, so I'm going to say 50 is equal to my slope, which was 10.25, and multiply that by my x value, which is 1, plus my own unknown, which is my y-intercept. And then let's calculate it. Well, I know 10.25 times 1 is just 10.25. And then the opposite of positive 10.25 is negative 10.25. So we're going to subtract 10.25 from both sides of the equation to eliminate it on our right-hand side. And 50 minus 10.25 is going to give us approximately 39.75. So our B should be 39.75. If I write that as an ordered pair, our y-intercept is at 0, 39.75. Alright, we've got our m, we've got our b. We just have to insert those into our equation here. So, y equals my slope, which was 10.25, multiplied by x, plus our y-intercept, which was 39.75. And guys, that's the approximate equation for the line of best fit. Alright, let's look at step E. So we're going to use this equation to make a conjecture about the score a student will earn by studying for 6 hours. Well, that means he is studying for 6 hours. That's what we should use for our x value. So let's insert 6 for our x value. So I'm going to say y equals 10.25 multiplied by 6 plus 39.75. And 10.25 multiplied by 6 is going to give us that y equals 61.5 plus 39.75. And when we simplify that by adding the terms, we can say that the student would approximately get a 101.25. Now, is that a realistic score? No, but going off of the data and going off the line of best fit, and if it did not have a cap at 100, the student could potentially get a score of 101.25. Alright guys, now it's your time to try a problem. So go to the next step and complete the required work for the data set. Have a great day.